هاي كيفكم اليوم؟ Okay, in this session we are going to solve the logarithmic exercise. In the first term, this one is for general science. Also, life science, uh, you should solve this exercise. Please pay attention. It is a good exercise. Now, before starting, we have one rule that we should understand, that integral from a to a f of x dx equal to 0. Whenever the bounds are equal, then the integral is 0. This is the first rule. The second rule, derivative of the integral from a to x f of t dt, derivative of the integral from a to x f of t dt equal f of x. Derivative and integral, they are opposite, they cancel each other. Also the same rule, if we have integral from a into ux f of t dt, derivative of this integral equals u prime of x first. We make the derivative of u prime, this is the derivative of this expression, times f of u of f of u of x, by replacing t by u. Now we go back to the first exercise. Okay, the first exercise, our exercise number 3. Here we have the function g defined over 0 plus infinity by gx equals 2x cubed minus 1 plus 2 ln x. It is a very important exercise. Please calculate the limit as x tends to 1, of integral from 1 to x g of t dt over x minus 1. So to calculate this integral, we replace x by 1. By replacing x by 1, we get integral from 1 to 1 over 1 minus 1. Integral from 1 to 1, it is 0, and 1 minus 1 is 0. We get 0 over 0. So limit as x tends to 1, integral from 1 to x g of t dt equals integral from 1 to 1 g of t dt, not dx, over 1 minus 1 equals 0 over 0 indeterminate. So whenever it is 0 over 0, we have to apply Hospital's rule. Hospital's rule says whenever the limit of a fraction is of the form 0 over 0 or infinity over infinity, then this limit is equal to the derivative of the numerator over the derivative of the denominator. So limit as x tends to 1 of g of t dt, integral from 1 to x over x minus 1. By using Hospital's rule, بالexam you have to say that you have used Hospital's rule. It will be limit as x tends to 1, derivative of the numerator, derivative of x minus 1 is 1. Now it will be limit as x tends to 1 here. Derivative of the integral, derivative or integral, they cancel each other, remains gx. we replace t by x, which becomes gx, equal limit as x tends to 1. This is gx to x cubed minus 1 plus 2 ln x over 1. Now we replace x by 1. It becomes 1 cubed is 1 times 2 is 2 minus 1 plus 2 ln 1. Ln 1 is 0. We get equal 1. This part half point. Now we go to the other part. Part 2. Calculate limit as x tends to 0 plus. 0 plus, we replace x by 0. 2 into 0. 0 cube is 0 times 2 is 0 minus 1 plus 2 ln 0. Ln 0 is minus infinity, so we get minus infinity. So limit as x tends to 0 plus of gx equal 2 times 0 cube is 0 minus 1 plus 2 ln 0 plus ln 0 plus is equals minus infinity. Now limit as x tends to plus infinity of gx. Limit as x tends to plus infinity of gx. As x tends to plus infinity, we replace x by infinity. Infinity cube is in plus infinity times 2 is plus infinity. And ln infinity is infinity. So infinity plus infinity is infinity. Limit as x tends to plus infinity of gx equals plus infinity minus 1 plus infinity. It will be equals plus infinity. Study the sense of variations of g. Then draw its table of variations. Study the sense of variations of g. We have to calculate g prime x, study its sign, and set up the table of variation. So gx is equals gx equal 2x cubed. Derivative of 2x cubed is 6x squared. The derivative of ln x is 1 over x. We see 2 over x. We see 6x squared plus 2 over x, which is positive because x is positive here. 2 over x is positive, and 6x squared is positive. So g is strictly increasing. So we put x domain, which is 0 plus infinity. G prime x, gx. The sign of g prime is positive, and it is strictly increasing. At 0, we get minus infinity, and at plus infinity, we get plus infinity. Please put the table here. Don't miss anything. At 0, you have to put minus infinity here. At plus infinity, you have to put plus infinity. Okay, this part 3/4, and the previous part is half point. Now part 4. Prove that the equation gx equal to 0. Prove that the equation gx equals 0 admits a unique solution alpha. Okay, we can show it in 2 ways. First way, I can say here, g is increasing from minus infinity till plus infinity. G is continuous and strictly increasing from minus infinity till plus infinity. Then its curve will cut the x-axis once, since it is increasing from a negative value to a positive value and continuous. So the curve cuts the x-axis once. So the equation gx equal to 0 admits one root. Or I can say g is continuous and strictly increasing over 0.8, 0.9. G of 0.8, by using the calculator, you get minus 0.4, which is negative value. G of 0.9 equals 0.24, which is a positive value. So since 1 is negative, G of 0.8 is below the x-axis. G of 0.9 is above the x-axis, the point, So alpha is between 0.8 and 0.9. Now part 5, deduce the sign of g over 0 plus infinity. Deduce the sign of g over 0 plus infinity. We can deduce it either from the table of variations or we can do a sign table. From the table of variations, I add alpha to the table of variations. At alpha, let g is 0, I put here 0. If you notice that for x equal alpha, gx equal to 0. Between 0 and alpha, is that x between 0 and alpha, g is increasing from minus infinity to 0. Between 0 and alpha, g is increasing from minus infinity to 0, means g is negative. So between 0 and alpha, g is negative. From alpha to plus infinity, g is increasing from 0 to plus infinity. So since g is increasing from 0 to plus infinity, then g takes positive values. So I repeat, I add alpha to the table. At alpha, I get 0. Between 0 and alpha here, the x between 0 and alpha, g is increasing from minus infinity to a 0. All the values are negative between minus infinity and 0, so gx is negative. Between alpha and plus infinity, we have g is increasing from 0 to plus infinity. All the values are positive, so gx is positive. Or I can make this table. I can put here x, gx, 0, alpha, plus infinity. I put here 0. To note a sign, I can take a number greater than alpha. Alpha is between 0.8 and 0.9. If I take, instead of x equal 1, if I replace x by 1 in the function f, إذا حطينا محل ال x1 بالfunction, we get 2 minus 1 is 1, plus 2 then 1 is 0. So we get 1, which is positive. So I can put here positive, here is negative. And after doing this table, you have to state that gx equal to 0 for x equal alpha. Gx is negative for x belongs to 0 alpha. And gx is positive for x belongs to alpha plus infinity. Now we get to the part B. Part B, we have the function f, another function f defined on 0 plus infinity, the same domain, by fx equals 2x minus ln x over x squared. So we have the function f defined over 0 plus infinity by fx equal 2x minus ln x over x squared. And C is the representative curve. 1 unit equal 2 centimeters. Prove that the ordinate axis is an asymptote to C. How to prove that the ordinate axis is an asymptote to C? The ordinate axis يعني ال y-axis. The y-axis عنده equation x equal to 0. So we have to calculate the limit as x tends to 0. وإذا أنتم ما فهمتوا, if you don't understand the question, you have the domain. Always we determine the limits at the open bounds of the domain. So the ordinate axis, as I told you before, it is the y-axis with x equal to 0. If we replace x by 0 in f, 2 times 0 is 0 minus ln 0 over 0 plus. Ln 0 is minus infinity over 0 plus minus infinity. Minus times minus, we get plus infinity. So limit as x tends to 0 plus of fx equals 0. 2 times 0 is 0. Minus ln 0 plus over 0 plus. Ln 0 plus is minus infinity. Times minus, we get plus infinity. So x equal to 0, or the y-axis, or the ordinate axis, is a vertical asymptote. Half point. The previous part also half point to study the sign of gx. Now, Calculate limit as x tends to plus infinity of fx. We are going to calculate limit as x tends to plus infinity. Limit as x tends to plus infinity. We have, if we replace x by infinity, we get infinity minus infinity over infinity. هلا limit of ln x على x هو 0 as x tends to infinity. Also limit of ln x على x squared will be also 0. So we get plus infinity. So limit as x tends to plus infinity, 2x minus ln x over x squared. It will become infinity minus infinity over infinity. Ln infinity is infinity. And infinity square is infinity. So infinity over infinity is indeterminate. So we apply Hospital's rule. Always you have to pay attention. You don't apply Hospital's rule بس للفراction, not that 2x, you make the derivative of 2x. So limit as x tends to plus infinity, we have to state that we are going to use Hospital's rule. 2x remains 2x. Derivative of ln x is 1 over x. Derivative of x squared is 2x. Then it will become limit as x tends to plus infinity of 2x minus 1 over 2x squared. This one, this 1 over x over 2x, it becomes 1 over 2x squared. 1 over infinity is 0, so we get plus infinity. And you are going to verify that the line D of equation y equal to x is an oblique asymptote to C. How to prove an oblique asymptote to C? You have to show that the limit as x tends to plus infinity lel fx minus yd equal to 0. So limit as x tends to plus infinity of fx minus yd will get minus ln x over x squared. So we get minus infinity over plus infinity. Indeterminate, we apply Hospital's rule. Derivative of ln x is minus 1 over x. ودerivative of x squared over 2x. Overall بيطلع minus 1 over 2x squared. Minus 1 over infinity, number over infinity is 0. Then the line D, y equal to x, is an oblique asymptote to C at plus infinity. Study the relative position of C and D. To study the position between a curve and a line, you have to determine the sign or to study the sign of fx minus yd. Fx minus yd equals minus ln x over x squared. This minus doesn't mean that this ratio is negative. Ln x could be positive, could be negative. So x is positive. So we solve minus ln x over x squared equal to 0. So ln x equals 0 in x equals 1. نعمل sign table for the position. This is minus ln x over x squared. This is position. Domain is 0 plus infinity. I get here x equal 1, so I put here x equal 1, and at 1 it will be 0. To know the sign, if we take a number greater than 1 and replace it in, since I need to know the sign of fx minus yd, I take this number, which is like 2, for example, and I replace it here. It's here minus ln 2 over 4, minus ln 2, which is negative, minus ln 2 is minus 0.7 over 4 is negative. So here is negative, here is positive. Positive, and C is above the oblique asymptote D. Negative C is below D. Don't write below or above. You have to full statement. C is below D. D cuts C. To find the point of intersection at 1, 2, if is equal 2, we replace 1 in the equation of the line. Line is y equal to x. For x equal 1, y equal 2. This is why we get 1, 2. So you replace this value either in the equation of the curve, which is f, or in the equation of the line to find the point of intersection, which is 1, 2. Now part 2. Verify that f prime x equal gx over f prime x equal gx over x cubed. So fx is equal to x minus ln x over x squared. Derivative of 2x is 2 minus derivative of ln x, u over v, this part, u prime is ln x is 1 over x times v, which is x squared, minus v prime, derivative of x squared is 2x ln x over x power 4. It becomes 2 minus 1 over x times x squared. It will become x squared over x, which is x, minus 2x ln x over x power 4. I can take x common here. It remains 1 minus 2 ln x over x cubed over x power 4. By simplifying x with x power 4, we get x cubed. We take the LCM, which is x cubed. It becomes x cubed times 2, 2x cubed, minus, pay attention for this minus. This minus is for all this fraction. It becomes minus 1 plus 2 ln x over x cubed, which is equal gx over x cubed. In this part كنا بنقول بس calculate f prime, show verify that f prime x equal gx over x cubed. So we get f prime x equal gx over x cubed. Now prove that f of alpha equals 3 alpha minus 1 over 2 alpha squared. F of alpha equals 3 alpha minus 1 over 2 alpha squared. F of alpha equals 2 alpha, we replace x by alpha, minus ln alpha over alpha squared. بس هون نحن طلعت معنا 3 alpha minus 1 over 2 alpha squared. ما في ln alpha، بس نحن طلع معنا بالcalculation whenever we replace 2 alpha minus ln alpha over alpha squared. So here we go back to the exercise. We know that, you know that here the equation gx equals 0 admits a solution alpha. We go back here, gx equal to 0 has a solution alpha. It means that g of alpha equal to 0. Since alpha is a root of gx equal to 0, then g alpha is equal to 0. So, but g alpha equal to 0. So 2 alpha cube minus 1 plus 2 ln alpha equal 0. Since I need f of alpha independent of ln alpha, I determine ln alpha. I calculate ln alpha. 2 ln alpha equal 1 minus 2 alpha cube. So ln alpha equals half minus alpha cube. I replace this ln alpha here in the, I replace instead of ln alpha here its value. So f alpha is 2 alpha cube minus ln alpha over alpha squared. I replace ln alpha by the calculated value here, 1 minus alpha square or alpha cube. So 2 alpha cube minus ln alpha, it becomes plus alpha cube minus half over alpha square. It becomes 2 alpha cube plus alpha cube, 3 alpha cube over alpha square minus half alpha square. Alpha cube and alpha squared remains 3 alpha minus 1 over 2 alpha squared. So pay attention here. We have to go back here since gx equal to 0 means g alpha equal to 0. Now part 4, draw the table of variations of f. Since we have seen that f prime x equal gx over x cube, x cube is positive, so f prime x takes the same sign as g. F prime takes the same sign as g. Here in part 5, we have deduced the sign of g. We have seen that between 0 and alpha, g is negative, yani f prime is negative. From alpha to plus infinity, we have seen also that G of x is positive means f prime is positive. So f prime x equal gx over x cubed means f prime x takes the same sign as gx. So x, f prime x, fx, domain 0 plus infinity. I put alpha, لأنه g of alpha is equal to 0. It means f prime of alpha equal to 0. So between 0 and alpha here, from this table here, between 0 and alpha, g is negative, yani f prime is negative, negative, positive, negative decreasing, positive and increasing. At 0 we get plus infinity. I put plus infinity, and this one is f of alpha. Part 5, determine the coordinates of the point E on C, where the tangent to C at E, tangent to C at E, parallel to line D. Two lines are parallel if they have the same slope. Two lines are parallel if they have the same slope. Yani slope of the tangent equals slope line D. Slope line D is 2. Slope of the tangent f prime. So by putting f prime x equals 2 and then solving for x, we get the value of x. Then we replace, we get the value of y. So TE, tangent at E, is parallel to D. The slope of the tangent at E equals slope at D. So f prime del x equals 2. Slope at D is 2. Slope of the tangent with f prime. This is f prime equal to, we cross multiply, we get 2x cubed minus 1 plus 2 ln x equal 2x cubed. 2x cubed minus 2x cubed, 2x cubed بيروح say simplified. 2 ln x equal 1, يعني x equal e to the half equal radical e. هيدا الأبسطة. To find the ordinate, since the point B is on C, to find the value of y, we replace the value of x in the function, in fx. F of radical e, you can use the calculator. We replace x by radical e, to radical e minus ln e to the half over e. Ln e to the half is half ln e. Ln e is 1. So we get this point. F is an antiderivative of f over 0 plus infinity. Study the sense of variations of f. To study the sense of variations of f, you have to study the sign of the derivative of f capital F. يعني we have to find f prime x. So fx equal antiderivative لل fx dx. So f prime x, it is equal derivative of the integral fx dx. Derivative and the integral cancel each other. We get fx. So f prime x has the same sign as fx. Once again, fx is equal to the integral of fx. To study the variations of f, you have to find f prime. F prime is equal to the derivative of the integral, which is equal to fx. So f prime x has the same sign as fx. But minimum lil fx is positive. So f prime x is positive. So f is increasing over 0 plus infinity. F is increasing over 0 plus infinity. Trace C and D. Suppose that alpha equals 0.85. This table حطيت محل الألفا 0.85, f of alpha we get 1.92. Now to line dy equal to x, for x equals 0, y equals 0, for x equal 1, y equals 2, here y equal 2. Now the curve is decreasing from 0 plus infinity to the minimum. It cuts the oblique asymptote at the point 1, 2. Then it goes to plus infinity near the oblique asymptote. Decreasing from 0 plus infinity here, yani, it is near the vertical asymptote. So you have to draw, noticing that the ordinate axis, our x-axis is a vertical asymptote. We have to draw it. So decreases to a minimum, then goes to plus infinity near the oblique asymptote. You can take particular points by using your calculator, if you like. It is better. Let t be a real number different from 1. T be a real number different from 1. Using integration by parts to calculate the integral from 1 to t ln x over x squared in terms of t, using integration by parts. The integration by parts, what is the rule for integration by parts? The rule is the integral of u dv equals u v minus integral of v du. Always, integration by parts concerning logarithm, I take u the log part and dv the other part. So u is the log part and dv is the other part. So here I need to calculate the integral of ln x over x squared dx. I take u the ln part, ln x, du equal 1 over x dx. dv the other part. What remains the other part? Remains the other part, not x squared, 1 over x squared. dv equal 1 over x squared dx. Here should be dx here. V equals integral of 1 over x squared dx, which is equal to minus 1 over x. So integral from 1 to t ln x over x squared dx equal uv. uv minus 1 over x times ln x, we get minus 1 over x ln x between 1 and t, minus v du. v du minus 1 over x times 1 over x, we get minus 1 over x squared. Minus 1 minus times minus, we get plus, and the integral of 1 over x squared مثل ما شفناها هون, we get minus 1 over x. So first here we get minus 1 over x. First we replace x by t. It's here minus 1 over t ln t. We replace x by 1, we get 0. Then minus 1 over t minus 1. So minus 1 over t ln t minus 1 over t plus 1. And the last part, calculate or deduce the area in centimeter square. What will be the area? The area هي integral from 1 to t yd minus fx. Why put a yd minus fx? Because if we look to the curve between 1 and t, the line d is above the curve c. So I put yd minus fx because the line d is above the curve c. So the integral will be integral from 1 to t ln x over x squared dx. We have determined this integral. طلع بهذا الفورم minus 1 over t ln t minus 1 over t plus 1 u squared. But u is 2 centimeters. It is 2 centimeters square. It will become 4. So 4 into centimeters square. And finally, calculate limit as t tends to plus infinity of at. Limit as t tends to plus infinity of at. Limit as t tends to plus infinity of at. It's here minus ln t over t, which is 0, minus 1 over infinity is 0, we get 4 centimeter square. Okay, this is all about this important exercise.